Hey everyone, so today we are continuing with exponents, but it's going to be, well actually powers and quotients, so kind of like dividing. Last lesson was all multiplying. So if you look here, again the properties I put over here on the left hand side, and then this is kind of like the algebra formula type deal, and then the explanation in words. So the first property is called the quotient of powers, and remember quotient just means what's the answer to a division problem. So it's basically when you're dividing two powers, okay? And when we're dividing two powers with the same base, you keep the base and subtract the exponents, which should make sense because the last notes we took, we said when multiplying powers at the same base, we kept the base and added the exponent. Here we're subtracting, multiplying and division are kind of opposites, so add and subtract also, you would think, hey, it's the opposite. But that's the first property. And then we also have a power of a quotient, which again, the names of these, I wouldn't say I'm not too concerned with you memorizing them, but you should recognize what we need to do when you see the problem. Because this one's called quotient of powers, and this one's called power of a quotient, which to me sounds confusing. But again, I'll explain it. This one is when you're raising a power, a quotient to a power. And again, we had something similar to this where we were raising a product to a power, and I have put in here we distribute the power. Okay, the same thing is going to happen here. You got to distribute the power to everything in the numerator and everything in the denominator. Okay, so this becomes x to the a power and y to the a power. So the key word there is distribute. And again, if we keep going with these properties, let me raise it up quite a bit. And then we have some other ones that aren't necessarily quotients, but they do go in this section. The first of negative exponents. In math, they don't like to keep negative exponents, so if you ever see a negative exponent, you also see this in like the rules. It'll say answers should only contain positive exponents. But anyway, to get rid of a negative exponent, you just have to write the reciprocal of whatever is being raised to that negative exponent. I like to think of it's just going to change locations. Like if something's up top, it's going to go to the bottom. If something's on the bottom, it goes to the top. And that's how we get rid of the negative exponents. Once we move it from top to bottom or bottom to top, it changes signs. Okay. So again, I would think like this is up top in the numerator with a negative, and then it goes down to the denominator and it becomes positive. And same thing with this one. This is in the denominator with the negative exponent, and then it moves up to the numerator with the positive exponent. Or reciprocal. Remember, reciprocal just means something that's flipped. So negative exponents are the reciprocal of positive exponents. And then we have zero power, and that one's pretty straightforward. Anything raised to the zero power equals 1. Right? We have that there. So let me lower it so we can get our examples in here. And then here's the examples. Again, this one is quotient of powers. So whenever you're dividing powers at the same base, you keep the same base and subtract the exponents. So this is 9 to the 8th power. Now, you can always do this, but if you do not remember, I'm going to show you a different way to solve this one. Like B, I could use that shortcut, but let's say I don't remember that rule. I could expand it. Remember in the last notes we wrote the expanded form, like into the 3rd power. Well, I know that tells me I have 3 n's, right? And then into the 9th power, that tells me I have 9 ends. And again, I mentioned this in the last class. The only bad part about this is it does take some time. However, it does give us the correct answer. So once you expand everything, what you want to do is cancel the terms that they have in common. And then count up how many ends are left. 1, 2, 3, 4, 5, 6. There's 6 ends in the denominator. And then on top we would just put 1. Because n divided by n is 1. Right? Do not put 0. Okay? And that's it. This is the other method of solving this. Again, I did not want to write 9 13 times, so I used the shortcut here. But and I could have used the shortcut here. 3 take away 9 is -6. It needs to go down to the bottom. So if you look at B, we have 14x cubed divided by 21x to the 5th power. If you have coefficients in front, try to simplify them. Again, I like to look at this as separate problems. So first, let's simplify 14 over 21, where you can divide 14 and 21 by 7, and when you do, you get 2 over 3. Okay, so that's this part simplified. And then if we simplify this part, we know if I subtract them, I get 2, and it has to go down here at the bottom. Because again, imagine if we expanded this, there'd be 3 x's up top, 5 x's in the bottom. We'd cancel them, and we'd be left over with 2 x's on the bottom. And that's the answer. C, this is power of a quotient. Again, you got to think, hey, I need to raise the numerator to the power of 3 and the denominator. And it's everything in the denominator. And then I would simplify anything if there was powers at the same base. There is none here. So that's our answer there. And then the last two, there's different ways. I'll show you more ways to simplify this while we do our class assignment. But the first thing I would like to do is take all the negative exponents and make them positive. And if anything is to the 0 power, I'm going to change that to a 1. So I'm going to rewrite my expression. So I'm going to start with the 4. There's nothing I can do with the 4. Now this m to the -3 power, that is going to go down to the bottom. Because again, it's negative, and to make it positive, it just switches sides from top to bottom. And then n to the 0 power, well, that's 1. Okay, so I dealt with everything in the numerator. Now if I deal with stuff in the denominator, the 3, well, it's just 3. There's nothing we can do with that. Then we have m to the 2nd power. That's going to stay there. It's a positive exponent. It's okay. And then we have n to the -5 power. Because it's negative, we have to move it. And then we're going to move it to the top. And when we move it to the top, it becomes positive. Oh, there we go. And then look at the numbers. 4 times 1 is just 4. So we have 4 on top. We have 3 on the bottom. That does not simplify. So it stays as 4/3. If you look at the top, you also have n to the 5th power. And then if you look at the bottom, you have n to the 3rd power and m squared. This is a product of powers. Remember from last class, if you're multiplying powers at the same base, you keep the same base and add the exponents. And that's it. There are no more bases with the same, or powers with the same base that we can combine. So that's the answer there. And then E, again, what I like to do first is go through I'm going to do this last, raise it to the second power. But what I'm going to go through first is go through and change any exponents and combine stuff that I can combine. So if you think about this negative power, that one has to come down to the bottom. Okay. Now on top I have 4 times 3. So I'm going to write that as 12. I have this y to the 4th power up here and this y to the 4th power up here. So I know that's y to the 8th power. So I dealt with the 4, I dealt with this one, I dealt with that. The only thing left is this x. Okay. And then on the bottom, that came down to the bottom. So I'm going to put that over here underneath the x. And then you still have this 4 and the y squared. Okay. And we still have this outside 2 power. Next I'm going to simplify the inside even more. So 12 divided by 4 is 3. I know that's 3. You have, if you look at this part, we're dividing powers at the same base, so we subtract the exponents. 8 take away 2 is 6. So we have y to the 6th power. And then also think about, like there's 8 y's on top and 2 y's in the bottom. Well, we know there's 6 more y's on top, so that should go on top. And then if we deal with the x's, again, I'm going to cover that part up. We have x to the 1st power up here, x to the 4th power down here. If you subtract those, you get 3. Well, that has to go in the denominator, because again, there's more x's down here than there is up top. And then now that I've combined everything and simplified my coefficients, now I'm going to distribute the 2. The 2 has to go with the 3. It has to go with the y, and that's going to be y to the 12th power. And it has to go down here in the denominator with the x, and that's going to be x to the 6th power. And that is it.